Hello, everyone. Okay, now let's resume our next topic for lecture, which is energy. So today we're going to talk about introduction to energy. What is it? How is it present in our everyday lives? And what are the impacts of energy today? So we're going to be talking about that. So mostly this lecture is more of a conceptual one, but there'll be some exercises we can do. Okay, so we use energy to run our cars, power our homes, make sure we're we're all living a healthy life, make sure we're fed, make sure we can have take showers, take baths. It's pretty much an indispensable part of today's world. And one of the consequences of energy is how to use it more efficiently, safely, and I guess more importantly, how to make sure it's kind of conserved, and we're not wasting energy in the forms of like other forms of energy. So we want energy to be efficient as possible. Okay, so you know we get energy from food, we use it to exercise, we can use energy to get through one place to another, and it powers our homes, right? Okay, so if we look at this like pie graph here, or pie chart, it tells us our relative percentages of how we get our energy today. So most of it is still around 70% is still due to petroleum and natural gas, or non-renewable feedstocks. So pretty much oil. So we get most of our energy from the natural oil that's found on Earth through various very extreme extraction measures. So they're very one of the consequences of using these non-renewable sources is that once they run out, we'll kind of be in dire straits. And much of the natural disasters, I believe, is a consequence of trying to disrupt the natural kind of the natural resource of crude oil, and these kind of oil fractions where we get most of this energy from. That is probably a consequence of us kind of disrupting the balance of the planet, to put it in a nice way. Okay. We do get some power from nuclear. Nuclear is not a good idea in my opinion. It just creates so much waste, and you can't really do anything about it. So nuclear, we do use nuclear. Nuclear though is relatively clean. I mean, it has like no. What I mean by clean is that it doesn't produce like any hazardous, I guess, byproducts, or it doesn't. It's kind of like it's clean in the sense that like when you use oil, you produce CO2, so you're going to produce greenhouse gases. Nuclear doesn't really do that. It does produce waste though in the form of like elements that are not very reactive, I guess, but they could potentially be radioactive, but in that sense, usually if something's radioactive, usually it has a half-life, but it really depends on what the element is. So nuclear has its downsides, and I'm not really a big fan of nuclear chemistry or nuclear energy, but you can't deny its usefulness in terms of generating energy, and that's where we get lots. If we need lots of energy, that's where we get that from nuclear, because most of the energy that is pretty much if you want to get a lot of energy, you can tap into the power of the nucleus of atoms. But we're not going to talk too much about that. You may talk about nuclear. You probably see nuclear chemistry in Chem 401 though, next semester. Okay, so electric also is still relatively a short supply, so you don't see a lot of like power stations as frequent as gas stations. Like, you see a gas station maybe on every block, every few blocks. Well, you don't see the same thing for a power station, so it's not really widespread right now. And the one downside of going to full electric is that one, you have to buy an electric car, which is much more expensive, and two, it'll put a huge strain on the power grid. So if there's a power failure and your house is fully electric, yeah, so it'll be it won't be good. But I guess most of the appliances in our homes are electric, so it won't be much difference than how we deal with things today. But if your car's electric and it runs out of battery, you're kind of toast. So honestly, perfect, a much more balanced sort of society would be a mixture of these things. Some parts natural gas, some parts petroleum, and some parts electric. So if we were kind of like lower our dependence on petroleum, I think it will last much longer into the future, and we wouldn't have to do these excessive extraction techniques, fracking of oil, of crude oil to get these gas mixtures, which is a prime component of different kinds of energy, fuel, heating, etc. Coal is still used in some parts of the United States and also other parts of the world, like in Europe. But one thing we want to highlight is this renewable energy, this green pie graph here. And you see renewable energy, it has a bunch of subdivisions here. Geothermal, so getting energy through, I believe that has to do with extracting energy from rocks. And then solar, solar panels, not really universal now. I haven't gotten on the solar train here. Too expensive in my opinion, and when it's not particularly, if you don't live in a particularly sunny area, probably not good for you. Hydroelectric is a good one, but this only works if you have if you have access to water. So this won't be particularly good for places that are not near water, like these central states and stuff. So it's really hard. Wind, we have wind power, but wind power it has its own problems. For one, most of the wind, like areas on the earth wind, are probably not as accessible to some states that are probably not near windy areas, and you would have to build wind farms, and those are probably a little bit too expensive to build on like a massive scale. So what the area I kind of research is biomass. So what that means is we get fuel, like how we get fuel from petroleum and natural gas. We get it from renewable resources or biological resources. So like if you take cellulose, which comes from in the forms of plants, trees, so forth. So if you took trees that have died and you take the wood or what's left over the tree, you can actually convert that to certain chemicals that can then be turned into fuel. So it's kind of like, but the problem with that is you're still going to emit CO2. But your source is renewable, so you could just plant more trees and kind of use that as a renewable resource, right? You plant the trees, use it exclusively for producing energy. So you harvest the resource, convert it to fuel. Then you get new seeds, replant the same trees. So it's kind of like you get a biomass farm and a biomass plant. So it could potentially replace petroleum plants or fossil fuel plants, power plants. But it's probably not as feasible because you also have, well, I won't say it's not feasible. It will have some contribution. It's definitely the future, but the main issue is does it really decrease our carbon footprint? Probably not, and it's going to be hard to get these ideas passed. Like the EPA, Congress. So it's kind of a tricky situation here, but Congress is just like, it's really hard to get anything past Congress these days, especially anything with the Green New Deal, because everyone hates anything to do with green or like renewable energy. If they touch their precious petroleum or natural gas, they tend to like freak out and be irrational. But you gotta think about like the temperatures of California getting hotter all over the world, so we have to think about not destroying all our forests and think about what they do. So I think in the future we will have to really think about kind of terraforming or like re-engineering our atmosphere, because at the rate it's going, we're constantly putting more CO2 in the air than removing it. So we have to kind of figure out a way to make all this work. And I think the best way is to reduce our dependence on petroleum, so we're not producing more CO2. Then we're not producing more CO2 than we're consuming it, because we need plants and pretty much trees to consume CO2, so it takes it out of the atmosphere. So if you get rid of all those trees and just put more CO2 in the air, it's not really going to help anything. So the idea is, if you build biorenewable farms, that CO2 it takes from the air, you could generally make it the cycle carbon neutral, because it takes CO2 in the air, and then once you convert all of those trees or biomass farms into energy, all the CO2 will just be regenerated. And theoretically speaking, if you build enough farms, you can make the CO2 cycle neutral, so there won't be a surplus of CO2 produced as there is now, because we're just taking petroleum, which comes from oil, and there's no way for the CO2 to be recycled unless you have something like carbon capture machines or more trees. But like in Brazil, what they're doing is the rainforests, they're continually cutting down the rainforest to plant, to build new like architecture. So, but the problem with that is if you build architecture, right, it's going to be probably need energy to be powered, right, and that energy is probably going to be petroleum or coal, and that will produce more CO2. So you're effectively decreasing your ability to reduce CO2 in the air. So yeah, not an easy solution. So that's how energy is kind of, it's complicated, right? So it really depends on you, the students, because you're pretty much the future. I've studied chemistry for the last decade, and there's no easy solution if we can't get anything done, like any realistic measures passed. If we can't do that, we're just kind of shooting ourselves in the foot here. So the energy situation is complicated. So, but if we just turn a blind eye onto it, we're just going to waste the planet away. And yeah, and I don't know about you, I don't plan on going to Mars. Okay, so Depending on how things look in the world, like a few years from now, who knows? I may have to step away from teaching and actually go and help do something about it. But I'm always looking out for new ways to kind of help contribute our energy, solve our energy problem. So it's just something I want students to think about. Like, think about how you consume things, how you recycle, purchase things, play games. Like have a really nice computer, consume so much energy. That's also contributing to our energy usage. So it's not an easy situation to reconcile. But anyway, so biofuels is how chemists now and pretty much an area of science is dedicating their efforts to reducing our dependence on petroleum and natural gas. And the problem with petroleum and natural gas, they use flammable compounds as energy. Well, the main problem with petroleum and natural gas is that it's very energy intensive, and it's just it's not carbon. The cycle is not recyclable, so you can't recycle the CO2 generated. So that's not going to be a very good way to get our energy, especially in the future. This has been around for decades, probably maybe even a century. So it's really I don't know. I think it's kind of sad that we're still dependent so much on these energy sources. But the thing is, it's simple, it's cheap, and it meets our energy needs. So it's hard to move away from that. But that's one of the big challenges of the future generation. How can we kind of revolutionize our energy needs? Okay? All right. So let's move on here. So that's our energy consumption here. Okay. So our total, and you see these total energy thermal units. See, they're in the quadrillion units, so it's a lot. But energy is always a constant process. It's neither created nor destroyed. So we need to work on a way to kind of make energy more efficient without causing it to be converted to other forms of energy. So we need to think of new ways like that. Okay. So we rely on petroleum because it contains hydrocarbons, which are compounds that only contain carbon and hydrogen atoms. And there are many compounds in crude oil that allows us to use it for energy because it's a good source of energy because of the high heat content within the molecules. So this is where pretty much gasoline comes from. So some examples are butane. You can find that in like lighter fluids. Oh, but this isn't butane. This is, or I drew an extra CH2 here. So yeah, the book got it wrong here. So it should be that. There you go. So just one extra carbon there. So isobutane is an isomer of, so not isobutane, isopentane. So that looks like butane but has an extra methyl group. Okay. So butane is used in lighter fluids. So you can find this in like lighters. So fluids and lighters. Because in lighters, you don't need a lot of energy to spark that flame. And butane, when compressed, it becomes a liquid. So it's pretty convenient for that. Octane. So octane and isooctane, they are the compounds that are responsible for gasoline. So many of the gasoline, much of the gasoline we use is based on the percentage of isooctane, which has a high energy content. So usually branched. So you see there the octane is a straight chain alkane, whereas isooctane is branched. So usually branched alkanes have higher energy content. And so the octane rating is based on the percentage of isooctane in your gas mixture. So you see here, but usually when we try to, so you may think, oh, how do we separate these compounds from mixtures? Well, it's not very simple and it's very complicated. So usually gasoline is not just simply octane. It's a mixture of more than 500 hydrocarbons. And most of them are liquids between 6 to 8 carbon atoms. So although we do purchase our gasoline based on an octane rating, pure octane doesn't burn very well. So in practice, is not very useful as gasoline. So usually we test our gasoline, how well it burns, by comparing it to the burning of isooctane. So that's where we get an octane rating. So if it burns as well as isooctane, that means, okay, it'll produce a similar heat content or something, along those lines. So it's based on the isooctane rating. Okay? All right. So let's stop here and we'll pick up in the next video. Sorry about a little rant about energy over there, but it's a particularly important topic, especially how it relates to the world today. And in a future assignment, I will ask you to make a video about something you learned in this class and how you can apply it to something you kind of care about outside of the classroom. So it's kind of like where we revisit chemistry's role in society and how you can see how chemistry can play a big role, or how you see chemistry not just in the classroom, but where do you see it outside of the classroom. And it could be anything that you are particularly interested in, like pollution, like chemical pollution, or like living conditions in certain parts of the world, government's role on how chemicals are regulated, stuff like that. All right, I'll see everyone in the next video.